So welcome back to the 12-factor part 3. In this video, I'll cover the dependencies section of the 12-factor app. It'll be a step-by-step walkthrough. So they say at the top of it, explicitly declare and isolate dependencies. Okay. So I'm guessing dependencies are like these libraries that the app itself depends on. Most programming languages offer a packaging system for distributing support libraries, such as CPAN, or Perl, or Ruby gems for Ruby. So most languages have libraries they depend on. Third-party libraries is what they're saying. Libraries installed through a packaging system can be installed system-wide or scoped into the directory containing the app. So either you can install a dependency globally, I mean by system-wide, install, let's say you have a Mac computer, you can either install the package globally or you can scope into the directory containing the app. If you install into the directory containing the app, then it'll be easier to bundle it. So you know that all your app dependencies are in your app folder. So a 12-factor app never relies on implicit existence of system-wide packages. So yeah, that's what we're talking about earlier. So the 12-factor app doesn't rely on a package existing, assuming that, let's say you developed everything locally and you deploy it. You can't expect wherever you're deploying, you deploy nowadays to a cloud-based systems. When you provision a cloud-based, let's say you provision the EC2 instance, you cannot expect the newly provisioned EC2 instance to have the packages that your application depends on. So that's what they're saying. So it never relies on existence of system-wide packages. It declares all dependencies completely and exactly via a dependency declaration manifest. So every application should have its own dependency declaration manifest. If you look at node-based apps, you have a package.json. I'm not really familiar with Ruby. I mean, it looks like Ruby gems is another package manager, I'm guessing. Or CPAN for Perl is another package manager. So you have these package managers that are local to your application. Furthermore, it uses a dependency isolation tool during execution to ensure that no implicit dependencies leak in from the surrounding system. So they're saying, yeah, so whatever dependencies you have, your dependency isolation system will make sure that there are no implicit dependencies that leak in from the surrounding system. So the dependency isolation tool, in this case, make sure that we are not using any dependencies, even though you've installed a dependency inside your app using some kind of package manager. You want to make sure the dependency that you install is the one that your app is using. And let's say a system-wide, if there is a system-wide dependency similar to what you have in your app, that doesn't leak in. The full and explicit dependency specification is applied uniformly to both production and development. So they're saying the dependency specification, you have a package manager and you say, hey, I want Lodash and I want Moment, and these, like, your application depends on these two packages. So it should be applied uniformly to both production and development is what they're saying. For example, Bundler for Ruby offers the gem file manifest format for dependency declaration and bundle exec for dependency isolation. In Python, there are two separate tools for these steps. So anyway, so for coming to Ruby, they're saying the bundler for Ruby offers a gem file manifest for dependency declares. Looks like in your gem file, you declare all the dependencies for your application, and bundle exec for dependency isolation. Looks like bundle exec make sure that the dependencies in the surrounding environment don't leak in, surrounding system don't leak in. So whatever you've defined in gem file are the only files that are used by the application. In Python, there are two separate tools for these steps. Pip is used for declaration and virtual env for isolation. So in Python, they're saying uh, pip is used for declaring all your dependencies and virtual env for isolation. Virtual env will make sure that whatever dependencies you defined in pip are the only ones used by your app. Even C has autoconf for dependency declaration, and static linking can provide dependency isolation. So even in C, you could use autoconf for dependency declaration, and static linking can provide dependency isolation is what they're saying. No matter what the tool chain, dependency declaration and isolation must always be used together. Only one or the other is not sufficient to satisfy 12 factor. Okay. So looks like one of the apps we've developed, we use some global dependencies. So we'll have to take a look at it and see how we can make sure that dependencies, whatever dependencies we use, are always local. So they're saying you have to, for a 12 factor app, so dependency declaration and isolation must always be used together is what they're saying. One benefit of explicit declaration is that it simplifies setup for developers new to the app. Okay. They're saying one benefit of explicit dependency is that it simplifies setup. So that developers don't have to install globally. So let's say you have a code repository and you have your app in the code repository, they can just download. They can clone the app. Let's say it's in GitHub. They clone the app to the local environment, to their local desktop, and go in and install all the dependencies, and everything is available inside that one folder. So the dependency, uh, the what do you call that? Yeah, the dependency declaration manifest provides everything that's needed for the app, and dependency isolation tool will make sure that there is nothing that will leak in. The new developer can check out the app's code base into their development machine, requiring only the language runtime and dependency manager installed as prerequisites. So they will be able to set up everything needed to run the app's code with a deterministic build command. So once everything is local, so in case of node-based apps, let's say they have a package.json file, they'll be able to just do a simple npm install, and all the dependencies that are needed for the app are installed in one shot. So for example, the build command for Ruby bundler is build bundle install. So for node-based app, it's npm install. For Ruby bundler, it's bundle install. While for Clojure Leningin, it is lean deps. Okay. So 12-factor apps do not rely on the implicit existence of any system tools. Examples include shelling out to ImageMagick or curl. So 12, they're saying 12-factor apps do not rely on implicit existence of any system tools. And they're giving an example like ImageMagick or curl. So if you need those tools, they're saying that you should figure out how to install them into using your package manager or your bundler, something like that. So it will be the entire thing is available in one shot, is what they're saying. While these tools may exist on many or even most systems, there is no guarantee that they will exist on all systems where the app may run in the future, or whether the version found on a future system will be compatible with the app. If the app needs to shell out to a system tool, that tool should be rendered into the app. So they're saying while these tools may exist on many or even most systems, there is no guarantee that they'll exist on all systems where the app may run in the future. So some tools like curl, I don't know if there is an equivalent command on Windows system for curl. So they're saying not all systems will have a curl command. Or whether the version found, so even if you have like a ImageMagick software on a system, it might not be the version that you want. If the app needs to shell out to a system tool, that tool should be rendered into the app. So they're saying if the app needs to shell out to a system tool, so if you want, if your app requires you to use a system tool, that should also be installed, that should also be packaged as part of the app. Somehow packaged as part of the app is what they're saying. So everything is local. Let's say you have a repository for your Hello World app. Everything should be available in that Hello World repo. So when the developer clones it to the local environment, they should be able to run a script, and that script should be able to set up their entire environment, is what they're saying. That's all I have for dependencies. In the next one, I'll cover config.